Mindsetters. Welcome to Mindset Learn, the home of the brain where you learn more, learn extra. You tuned in this hour with myself, Tebogo Precious, and Dina. How are you?
Thanks, Tebogo. I'm very, very well and very excited to be with the grade 11s today.
Wow, fantastic. Now, could you kindly let them know what to expect in today's show?
Sure. Last week we were doing some of the paper 1, the exemplar that the department put out, and we did some questions on equations, etc. Today we're going to look at specifically number patterns, functions, as well as finance. So we hope to cover those 3 sections in today's show.
Oh, fantastic. Now, I'm sure you guys are familiar with the Learning Hub, proudly brought to you by Samsung, which entails Learn Extra's material and content of the exam revision. Now, I just quickly want to show you a sneak peek why you guys should really enter the competition. It's really going to be beneficial for you. You can literally just look at the shows and follow through with your notes while you're busy watching the show. And you can actually check your marks, etc., and grade yourself. It's really a very cool device to have, you guys. I recommend you enter the competition because we are on lag 2. You do not want to miss out. Download the notes, get your unique number, enter the competition on the link I will provide shortly after this, and make sure that your number will be in the lucky draw. Otherwise, with that said, Dina, over to you.
Thank you. And grade 11s, I hope that you've got your paper ready and you your minds are really action-based as well, and that we're going to have a good session this afternoon. I have taken the questions from the exemplar, so let's get straight to it. Looking at number patterns, functions, and finance. And in this lesson, we're going to revise how to solve number patterns. We're going to do some finance calculations, and we're also going to work with functions. Now, if you think back to how long that took you in class to do, there's literally about 2 months worth of work, and we've condensed it into our hour together. So let's get straight to it. The first question, which has been adapted from the DBE grade 11 exemplar, is question 6.1. And the following number pattern is given: a half, followed by a quarter, followed by an eighth, followed by a whole lot of other numbers, and it must land up at 1 over 1024. So that fraction being our last term. And the first question is to explain how we would determine the 4th term of the sequence. Well, first thing to look at is what terms we actually considering. So this would be term 1, this would be term 2, term 3, and we have a whole lot of terms, and this would be the nth term, the last one. So if they're asking us to do something with the 4th term, we need to work out the 4th term. We would always start with the first term and see what's happening to get to the 2nd term. So try and develop a pattern so that we can then go on to the 4th term. So from the 1st to the 2nd, we can see that we've halved this half. From the 2nd to the 3rd, we see that we've halved a quarter. So we've taken a half of that, we've taken a half of that. So in asking what are we going to do to get to the 4th term, we're going to say we are going to take half of term 3, because that's what we have seen happening between term 1 and term 2. Half of a half is a quarter, half of a quarter is an eighth, so a half of an eighth would be a 16th. So half of an eighth would be 1 over 16. Okay, remember it says explain, so my explanation would be to take a half of term 3, as in the pattern seen above. Then we need to write a formula for the nth term. So we are actually taking each term and we're multiplying it by a half, so the sequence is actually geometric. And we have a common ratio of a half, so therefore the nth term would be 1 over 2 to the n. So it's exponential in fractional form, and the nth term would just be 2 to the n. Then we need to work out how many terms the sequence has. Well, the last term was given to us as 1 over 1024. So that means that 1 over 2 to the n is the same as 1 over 1024. And since the numerators of these fractions are the same, in order for us to be able to solve the exponent, we are just going to focus on our denominator, which is 1024. And which power of 2 is 1024? Well, I'm expecting you to be able to know your powers of 2. So if I double 4, I get 8. If I double 8, I get 16. If I double 16, I get 32. Double 32, I get 64. Double 64, I get 128. Double 128, I get 512. And if I double 512, I get 1024. So how many times do I have to double to get to 1024? So the first power over 1000 in taking your doubles is the 10th power. Why am I expecting you to know doubles? Because doubles is how you work with data, the amount of data that you can store in devices. So you get your 64 gigs, you get your 128 gigs, 512, and then you get this 1 terabyte or whatever it is. So you keep on increasing in powers of 2. So that's why those numbers are familiar. So 1024 is the first power that is above 10. So therefore, we're saying that 2 to the n is the same thing as 2 to the 10, and therefore n is equal to 10. So in other words, this sequence actually has 10 terms. Okay. The second question we're looking at today is around a quadratic pattern of the form Tn is equal to an squared plus bn plus c. And the moment we're dealing with that word quadratic pattern, we need to think about what the various typical characteristics of a quadratic pattern look like. And so we'll talk it through. Our first difference would be linear. Our second difference would be constant. So quadratic patterns have got those features. And then try and engage with the given information to work out maybe patterns within the series, maybe the first difference, maybe the second difference. Let's see what the question's saying. Aha, here we go. It's saying that the second term and the fourth term are both 0. And then some very important information here, that the second difference is 12. And because we've got a quadratic pattern, that implies that our second difference is constant. So remember, we're looking at features of this function. So our second difference, 12, is going to be constant. Okay? Right, so we've been given a lot of information. We've given the quadratic pattern, we've given what its formula looks like, we've given some information about 2 of its terms, and we've been given something about the second difference. Then we need to determine the value of the third term of this pattern. So what would be the third term? So we're looking for T3. Okay, best thing to always start off with, seeing we're looking with so few numbers, is to actually write down what we know in terms of the actual terms. So we have perhaps T1, then we have a T2, then we have a T3, and finally we have a T4. This term 1, they haven't told us anything, but they've told us that T2 is 0, and they've told us the T4 is 0, so the even numbers are 0. But they haven't told me anything about the first one, and they haven't told me anything about the third one. So your magic key when you're a mathematician is you let what you don't know be x and y, and somehow with the magic of algebra we're going to find out what those x's and y's are. Okay, so put in the information that you know, and this would be the quadratic pattern. Okay, and we know that with any quadratic we can find our first difference. So our first difference, I'm going to work out in this step, and our first difference would be 0 minus x, would be y minus 0, and would be 0 minus y. And I know that these three, they form a linear sequence, but they've also told me something about the second difference, that it's 12. So my second difference, I know, is 12. But let's first calculate it in its algebraic form. So it would be y plus x, because I'm taking this term and I'm subtracting it from that one, so I'm subtracting a negative x. These zeros don't play any role whatsoever, so they're actually meaningless in this case. So it's just really y minus that. And then this term minus that term would be a negative y minus a y. But in both cases, they've told us that the second difference is 12, and therefore this one is 12. And by using that information, we can actually find out what the third term is, which is the value of y. So let's find out which is easiest to work with. Well, it's actually easier to work with this equation over here, because all it is a negative 2y is equal to a 12, which makes y equal to negative 6. And if that's the case, then our sequence is actually showing, well, let's write it again, that we have a first term of x, but if we now know y, we can also work out what x is. So negative 6 plus x will be equal to 12, so x will be equal to 18. So let's write up the sequence as we've got the values. 18, we've got a second term of 0, we've got a third term of negative 6, and we've got a fourth term of a 0. That's what we were given. Right, let's see that we get this constant difference of 12. So our first difference will be negative 18. Our first difference here will be negative 6, and the difference here will be 6. So that in here, it will be minus 6 plus 18 will be 12, and 6 minus negative 6 will be 12. So that certainly is a quadratic pattern. We can test it via that constant difference of 12. Okay, so very nice question on the quadratic, and all we needed to find out was the third term, so we've done that. That's our value of 6. Okay, let us go and quickly do, let's just see here. Let's go to this one. Actually, I'm going to set this up as a little challenge question. Okay. Right, grade 11s, we've got a functions question. I know that functions is your favorite. So I'm going to leave you with a question during the break, and then you can tell us what it looks like on the page, and let's see which one of you is the first one to get it. Okay, here's the given information. You need to sketch the graph of f, which, if we look at it, it's a quadratic, and you've been given some very important information. You've been given that the range of the function is negative infinity to 7. You've been given that the a value is not 0. You've been given that the b value is positive, and you've been given that one root of f is positive and the other root of f is negative. So with those 4 critical pieces of information, how would you sketch f? What would it look like? Post that on the book, on the Facebook page, and let's see what you come up with, and we'll take a quick break. Over to you, Tipocho.
Wow, grade 11s, it is now time for our first break, and guys, I hope you guys are paying attention. As Neokneo says, it is our time, pre-matrix, no time to waste, revision indeed. He is right. Take advantage of our presence, make use of your resources, post all your questions on our Facebook page, and we'll be watching. We'll see you guys after the break. Welcome back, Mindsetters. I'm glad you guys are on par with us and actually paying attention. If you feel like you've missed anything, do not worry. The show will be available on YouTube and available for you guys to download. Don't forget to download the notes as well to get your ticket, the race number to our awesome competition for the Learn Extra Exam Revision Marathon competition. Do not forget to enter, guys. Time is running out. We are on lag 2 now, and there's only 8 tablets to be won. So make sure you get your number in the lucky drawer. With that said, Dina, over to you.
Thanks, Tipocho. Right, grade 11s. we need to get onto the finance now, and there was quite a lot of finance that you would have done this year. There was the calculation of appreciation as well as depreciation, and then there was also the calculations when you have a different interest rate working over a certain period of time. So we're going to look at two of those questions, and hopefully we can really answer some of your questions along the way as well. Okay, first question's up, and this is the section where it's very, very wordy. It comes from question 4 of the grade 11 exemplar. Let's get right to it. So 14,000 Rand is invested into an account, and the account earns interest at a rate of 9% per annum, compounded semi-annually for the first 18 months, and thereafter 7.5% per annum compounded monthly. So let's just highlight that as we go along. We have interest rate at 9% per annum compounded semi-annually for the first 18 months, and then we have a change in rate, and it goes to 7.5 per annum compounded monthly. Okay, so a very important word, this word compounded, because we know exactly what formula to be using, and this calculation is also done on a compounding basis. Okay, so we want to know how much money will be in the account exactly 5 years after the initial deposit. At grade 11s, I always find it very easy to draw a little table of what's going on. So if we start off in year 1, then if this had to represent my 5 years, I would then have year 1, year 2, year 3, year 4. Actually, that represents 4 years, 5 years. Okay, and in the first 18 months, which is a year and a half, so those are 18 months, we had a specific rate. It was being calculated semi-annually, and thereafter we were calculating on a monthly basis. So we had how many months after that to make up the 5 years? How many months in here? Well, it would be 1, 2, 3 years, so that would be 3 12s, which is 36, plus 6 months, so that would be 42 months. So in total, trying to get a grasp of what 5 years would look like in terms of the months that they've given us. So again, to go over it, first bit, we were working with 9%, and I've calculated in red, in green over here. So let me do the green one here as well. So this is 18 months, and thereafter we had a 7.5%. So this was 9% per annum compounded. I'm going to put an H for half yearly, so semi-annually or half yearly. And for the 42 months, we had a 7.5% per annum compounded monthly. Okay, so both these rates are annual rates, but they need to be compounded in different time periods. So we need to go and get the rate within that time period. So if this rate is per annum, if it's going to be compounded half yearly, I need to get the rate that's a half yearly rate, because this is actually an annual rate. So the half yearly rate, we would work out how many times would we be compounding in the year. We'd be compounding it twice. So it would be 9 divided by 2, or we would have a 9 divided by 200. Because the percentage must also be accompanied. And 9% means 9 out of 100. So 9 out of 100, and then I'm dividing by 2. So grade 11s, it's 9%, and then we're dividing by 2, which is times by half. So it would be 9 over 200. So this value here would be my rate per half yearly, per half year, compounded half yearly. So this would be my rate. In the half year, I would get 9 over 200. What about the monthly one? Monthly one, there are 12 months, so it would be 7,5 divided by 100 times a 12th. So it would be 1,200 per month, compounded monthly. So this would be my rate per month, and I'm going to compound my calculations monthly. So it's very important to have them, I almost like to call them like terms, because you must have the per and the compounding period the same before you can actually make your calculations. So you've seen here, I've made it per half year, compounded half yearly. Okay, semi-annual or half yearly, it's exactly the same thing. Okay, so now that we've got our rate, we've looked at that it's compounding, so we know what the compounding formula is, and therefore we can work out what the value is of the 14,000 Rand at the end of 18 months, and we can work out what the rate is at the end of 42 months. So just a reminder that once you have worked out what the value of your money here is, this becomes your new P for the next blue period. So your green period, you've got a 14,000 startup. It then grows to a certain amount, and that value that you've now got, it's going to become the new P for that. So I'm not going to do separate calculations. I'm going to do them all in one, just in the interest of time. So why did this yellow not stay there? Right. So we've got A equals P into 1 plus I to the power of N. Okay? And we have, we were told that our account starts with 14,000 Rand. So our A at the end of that period is going to be 14,000 Rand multiplied by 1 plus. Our rate is 9/200. Okay? And I'm going to ask you, how many times did you compound in the 18 months? We're not going to compound for 18 months because we're doing in half years. So how many half years are in 18 months? Good, there are 3. So we're going to raise it to the power of 3. Now this value is what you will have at the end of 18 months. This becomes our new P, and we're going to grow that by that value there. So that's going to grow by 7.5 of 1,200. Actually, let's just not forget our formula is 1 plus, eh? So let's just say 1 plus, it's going to grow by 7.5 over 1,200 to the power of, remember that the blue compounding period was over 42 months, and this was a monthly calculation, so our exponent is also in terms of months. So we've got to the power of 42. And grade 11s, once you've got that formula, you just plug all that into the calculator, and you'll find that your investment is now worth something quite marvelous. So let us see. Just bring it over across, and we've got our 14,000, which we're going to multiply by 1 plus our 9 divided by 200 to the power of 3. And we're then going to multiply that by 1 plus the 7.5 that we're dividing by 1,200. And we're raising that to the power of 42. Okay, and what do we get? We now have got a value of 20,755. Okay, 20,755. So over 5 years, you've been able to make another 6,000 Rand onto that account, and you've got a nice little interest of 6,000 Rand. So that would be a compound calculation. Right, let's go on to the next question. Question 4. An investment earns interest at a rate of 8% per annum, compounded quarterly. At what interest rate? Okay, let's go through that again. I always like to highlight my words. An investment earns interest at a rate, so the rate is 8% per annum, compounded quarterly. Let's put that into maths. 8% per annum, compounded quarterly. Okay, at what rate is interest earned each quarter of the year? So this would be per annum, but each quarter, how many quarters are there in the year, grade 11s? Each quarter, good, there are 4 quarters. So each quarter will have 8% divided by 2 per quarter, compounded quarterly. 8%, get it into a fraction, so it's 8 over 200. So that would be the quarterly rate that of the interest that you'd get. Okay? Or you could talk about 4% per quarter. Either that value, which is the same thing as 4% per quarter. That would be the same as well. Okay? And then calculate the effective, here's something that you've done this year, grade 11s, the effective annual interest rate. What is the formula that converts between effective and nominal? We've got a formula that doesn't appear on the formula sheet and that you need to know. And the formula is the same as your compound interest. It's 1 plus effective rate, and remember this is already inside there, it as a percentage, so we'd have to write it as I over 100, is the same as 1 plus your nominal rate over the year over your number of periods, all to the power of that same number of periods. So if you're dividing that by 2, you raise it to 2 if you're dividing that by 4. So half yearly 2, quarterly 4, monthly 12, so that's in 1 year, your nominal rate. Right, so if we want to do the effective rate on our quarterly calculation, that would be 1 plus I to the 1 plus I effective would be 1 plus our nominal rate over number of periods would be 8 over 200, and there are 4 quarters in a year, so we would raise it to the power of 4. So now we would go 1 plus I to the e. Get your calculator to work for you what that is. So we've got our 1 plus 8 divided by 200 to the power of 4 is equal to that. You'll then see how we must subtract 1 from that. So minus 1. So we get 0.16. But remember that the calculation, no, something's not right here. Let's just close that up. This is in quarters, and I've divided that into half yearlies. So I'm sure some of you are shouting at me on your screens. So that should be 8 over 400, because remember, n is the same as that. So if that's a 4, that must be a 4. Okay, converted into a percentage. So let's go back to our calculator. So we would have a 1 plus 8 divided by 400 to the power of 4. That's much better. We'd get that minus our 1. We get 0.08. And then we need to multiply that value by 100 in order to get our effective rate. So it's an 8, don't run away, little calculator. He gets shy. 8.24. There we go. 8.24 as a percentage. Okay. So that was 1.008 something. So that's the conversion between the effective and the nominal rate. Deborah, are there questions?
Yes, there are. I have one from Joanna Gangiho, and then she's asking, well, she says she doesn't understand why you made it to the power of 3 when the m value is 18 months.
Okay, that's a very good question. Let's just see if it's this one. Yeah. Okay. So the key to that question, why did I raise it to the power of 3 when I had 18 months? Why didn't I raise it to the power of 18? I would raise it to the power of 18 if I was compounding monthly. Then 18 would represent each of the months that I would be compounding the interest for. However, it says that I'm compounding, when I'm using my 9 months, I'm compounding it semi-annually. So I need to ask myself, how many semi-annual, I like to call them half-yearly, it's the same thing. How many halves are there in a year? I compounded once, 1 half, and I compounded twice at the end of the other half. So the question is, because we're compounding half-yearly, how many half years are there in 18 months? How many half years are there in 24 months? How many half years are there in 60 months? So I want to know how many halves are there in 18 months. That's what the question's saying. So in 12 months, I've got 2 halves. Another 18 months is another 6 months. So that would create your other half. So I'm going to compound that amount 3 times. I'm going to do it 3 times over 18 months because I only do it every 6 months. So the key is in the fact that the compounding is done every 6 months. So how many 6s going to 18? I'm doing it 3 times. However, if I was compounding monthly, I would be doing it every month, so I would raise it to a power of 18. So the clue is in the fact I'm doing it semi-annually. And semi-annually means that I'm going to be calculating every 6 months. So when they said that we'd covered that over 18 months, here's my 1 time, here's my 2nd time, here's my 3rd time. So how many times will you compound over 18 months?
Well, Joanna, I hope you have a better understanding now. We are quickly going to take a short break, and we'll see you guys in a few minutes. Welcome back, Mindsetters. I'm glad a lot of you are getting the answers to Dina's question correctly. Dina's quickly going to run you through it, but don't forget to post your questions on facebook.com/learnextra or mindsetlearn/live. And Dina, over to you.
Thanks, Lebogo. I think Facebook's got to develop some kind of application that you can put these maths drawings. Because you were very creative in your descriptions of how this parabola was going to look like. So I got some frowny parabolas, and I got some parabolas facing downwards. So I was imagining what you were trying to say, whether these parabolas would just be flat like they were tired or what they would be looking like. So definitely Facebook needs to upload some application that you can actually draw parabolas and post them up. Okay, so I'll quickly look through a challenge question. We had a range of to infinity to 7, so this means that this is a maximum value. And if a function's got a maximum value, then it increases to the maximum and it decreases. So some of you call that a frown, parabola, or arms down, or whatever. So it definitely will look like that, which gives me another tip. It tells me that A is negative. So we now have an A negative, we have a B positive, and what can we do with that information? Because we know that one root is on the negative side and one root is on the positive side. What I don't know is where's the axis of symmetry? Is the axis of symmetry going to be here, or is the axis of symmetry going to be there? So I need some help. What is going to sort that problem out? Where is that axis of symmetry going to be drawn? Well, we have the B information and we have the A information. So I'm going to do something very unmathematical, but I think some of you will understand. And that is that the axis of symmetry is defined by this formula, negative B over 2A. So if my B has been given to me as positive and my A has been given to me as negative, then my full quotient over here is going to be positive. So X is actually positive. So my axis of symmetry is positive, my axis of symmetry isn't negative. So I now can tell that I can draw this axis of symmetry there, and I've got one negative root, one positive root, and it's going to be maximum at 7, so I can really draw this to go through 7 and come down. So that's my 7. And there's my parabola. So everybody would be getting marks for their roots, one for the maximum value, one for the axis of symmetry for being on the correct side. Remember, the axis of symmetry, we always get it through that. If B is positive, doesn't necessarily mean that the axis of symmetry is positive, but in this case it did. It did say that. Okay, so that was the first of the challenge questions. Let's go on to what the exemplar actually had as one of its function questions, because they actually had 2. And I'm hoping that you will be able to see that because it's quite tiny. But that's the graph that you were given. Here's the y-axis, here's the x-axis, and these are the asymptotes for the hyperbola. So I'm going to draw the hyperbola in yellow. There's my hyperbola. And it comes through here. And in other words, this vertical line and that vertical line are the asymptotes of that yellow graph. And then this straight line goes through A and it goes through there. So those were the 2 graphs that were given. Okay, let's go back up to the information. Yellow graph is the hyperbola, and the pink graph is the straight line. sketch below represents the graphs of hyperbola and straight line, and we had point B which lied on the graph of G, and the two graphs intersected at points A and C. Okay, so we then have made we've made some connections. We've got the algebra, and I'm going to write it down here so we don't lose it. So f of x is 2 over x minus 3. Now, grade 11s, what does this information give us? What does this fraction give us? And this value here would be the x asymptote, and this value here would be the y asymptote. So if we go back to the graph, straight away we know where the asymptotes meet. They're meeting at 3, negative 1. Okay? Because this asymptote is x equals 3, and that asymptote is y equals negative 1. Okay. So without anybody asking us anything, we've been able to make those deductions already. What we don't know is what the pink graph is. They gave that to us as dx plus e. So we need to go and find that information. Okay, let's see what's up with the questions. Write down the equation of the asymptotes. Can you see we did those without actually... let me leave the graph up. We did that without actually going to the questions, but by analyzing what the given information was. So x equals 3 and y equals negative 1. Those are the asymptotes. X equals 3 and y equals negative 1. What is the domain of f? What is the domain referred to? All the x values of my set. And in this case, I can have every single value except my graph is broken at 3. It doesn't cross through 3. So the domain is going to be every single real number except it doesn't include 3. Okay, then determine the values of d and e correct to the nearest integer if the graph of G makes an angle of 76 degrees. Wow, grade 11s, look at this connection that we have to make now. Got to go back to the graph and say that this straight line has an angle of 76 degrees with the x-axis. Now tell us, what do you know about lines that are inclined to an x-axis? What is that integral piece of information that you connect the inclination with the line? Got it, it's the gradient, well done. So gradient is what connects the angle that a line makes with the x-axis. And the way it's connected is that the tan of 76 degrees is equal to the gradient of the line. So we now have that the gradient that they gave us was actually d. So d is equal to the tan of 76, which in this case we have a tan of 76, and that gives us 4. And they said correct to the nearest degree, so we're just going to write that d is equal to 4. Now that's the gradient of the line. If you'll go back up, you'll notice how the line also goes through this point 3, 6. So we can now substitute that point in. So substitute the point 3, 6. Therefore, we've got y equals gradient into 3 plus c, and we can actually erase this and fill it in with a 6. And so c is equal to 6 minus 12, which is negative 6. So our straight line is y equals 4x minus 6. That is the equation of the straight line. Okay. Okay, so it looks like we've run out of questions, but I think we need to have another question here.
Can I ask you a question?
Sure.
Dina?
Okay, next questions, yes.
The mindsetters think it's more of a correction than a question. They think you made a mistake.
Yes.
On, I think it's question 4.2.2. Let me just quickly find the question and then...
Well, that would be a bit difficult to find.
4.2.
4.2.
It's 4.2.1, sorry.
I don't know. What was the question about?
It was about percentages and the quarters. And
Yes.
you had to divide 8 by 4 instead of 2.
Yes, I corrected it later. I
Oh,
corrected in the
okay.
next section, yeah. That's right. That was a 4 and that was a 4. If you'll notice, we corrected it later there. Okay,
Okay.
great. So let's now just...
Oh, here's another one. King is asking, why do we use tan instead of cos and sine?
That's the definition of inclination. Did you hear that question? Why are we using tan instead of cos and sine? Because the gradient is connected through the inclination. That's what you do in analytical geometry in paper 2. So they've gone to fetch something that you've done in paper 2 into a paper 1 context. Gradient is always defined as a tangent of the angle that the line makes with the x-axis. Great, we're revising. Good questions that the mindsetters are asking. Okay, so let's, there we go. Determine the coordinates of A and of C. And we had the hyperbola there. And we had the straight line. And we've now got that this line is y equals 4x minus 6. And we had that this line was y, or curve, is 2 over x minus 3 minus 1. And we've got to find the value of point C and point A. Where does the pink and the yellow intersect? Grade 11s, when do lines intersect? When their y values are the same, so when we solve simultaneously. Great, that's applying our simultaneous equations. So we're going to find, solve for x and y simultaneously. And let me just double check that A, yes, A is the intersection, C is the intersection for point of intersection. So we're going to have 2 over x minus 3 minus 1 is equal to 4x minus 6. Grade 11s, be careful, you've got a fraction here. So I'm going to multiply by x minus 3 on both sides. So we've got 2 minus x minus 3 is equal to 4x minus 6 times this x minus 3. Right, so tidy up the algebra. 2 minus x plus 3 equals 4x squared. The bridge, minus 6 minus 12 is minus 18 plus 18. So I'm going to go into here, into the set here. So this is 4x squared minus, would make it a plus x, would be minus 17x. And this 5 onto that side would be 18 minus 5, which is plus 13, is equal to 0. Okay, let's try and solve this quadratic. I'm going to try and see if does 4 and 1 work. 4 and 1 and 13 and 1. 13 plus 4 is 17, so 4x and x, and 4 times 1 and x times 13. So we get negative 13, negative 4 is negative 17. So x is equal to 13 quarters, or x is equal to 1. And the y value would be 4 times 13 over 4 minus 6, which would be 13 minus 6, which is 7. Or y would be equal to 1, y would equal to minus 2. So this would be point C, and this would be point A. Okay, so if we go back to the graph, we're saying that point C's coordinates are, let's go, point C, 13 quarters and 7. And 13 quarters is 3 and a quarter. 7. And our point A over here is going to be 1, negative 2. Is that what we got? 1, negative 2? Let's just check. 1, negative 2, yeah. Okay, so we've got those green points calculated. Then we need to determine for what values of x. I like these questions where we need to determine where one is greater than the other. So let's go back to the graph for that. Where is g bigger than f? Question is, where is g greater than or equal to f? Where are you going, graph? Then f. Okay, grade 11s, the problem with this is a lot of you will try and insert the hyperbola and the parabola's equation, the hyperbola and straight line, and you will try and do it algebraically, and you'll get hopelessly lost because there's a lot of fractions and things going on. So don't try and solve that algebraically. Try and use your graph to help you, and I'll show you how. This is saying, when is the y value of g bigger than the y value of f? So go and find out, where does this happen? This is happening currently. Where? Where on your graph would you find that? Now, even better is to say that g is my straight line. So where is the y of the straight line greater than the y of the hyperbola? It's even better to define it in terms of their shapes. So where do I find that? And the best way is to actually start on your left, and you pick a point on your left, and you say, which graph is bigger? In other words, which y value is bigger? The y of my hyperbola at this stage is bigger, so the y of my straight line is smaller. Grade 11s, where will that change? If I keep moving my pen, where will that change? Well, the y values are the same there, and then they will change after that point of intersection. Can you see my straight line is now bigger than my hyperbola? Okay, grade 11s, use a ruler to indicate what you're doing. Just use a ruler and move it along. And then as you move your ruler along, you'll see, oh, okay, that stays the same until they intersect, because something happens when they intersect. So that nature changes. So the best way is to go to the graph and go and color in where this happens. Where's the straight line bigger? And we said it was from this point all the way to that point of intersection, because after that my hyperbola is much larger than that, so it's only in this region that's happening. But my y has got to be bigger than or equal to, so you can actually color in those values. And now that you know where that is happening, you now have to give an answer for the x's. The answer is that x must be smaller than 3 1/4, and it must be greater than or equal to 1. So you're giving your answer in terms of x's because you've now sorted out where it's happening for the y's. So it's very easy. Just use a little ruler and keep moving along. Okay? And then determine, so this we've done that. Determine an equation for the axis of symmetry of f which has a positive slope. So let's go back to the axis of symmetry of f, which has a positive slope. Well, what are the axis of symmetry of the yellow graph? Well, the first one, let's use a green one, is that you've got this line that goes through where the asymptotes intersect, and you've also got this one where the asymptotes intersect. So the positive slope is always y equals x plus c. The gradient is always 1, and this gradient is always -1. What you now have to do is you've got to find out where's the green graph going to cut the y-axis. And can you see that they always pass through this point where the asymptotes intersect, which in our case was the point 3, -1. So once you've got where they intersect, you can now substitute your 3 into y and your -1 into x, and you can actually find out what c is. So in this question over here, it would be the y value is -1, the x value is 3, so my c would be -4. And in other words, your axis of symmetry would be y equals x minus 4. And it is going down here along that side there. Okay, so that would be the axis of symmetry of the hyperbola. Are there any questions, Tebogo, on that?
Yes, I hope we will have time. Monica's asking for you to please do question 6.3 in the grade 11's exemplar.
6.3?
Mm-hmm.
I don't know if I have it. I don't know questions by number. Okay, I don't know. Can you ask her what question 6.3 is about?
Okay.
Because I'm only doing the ones that I said I would do today, which is functions in finance. So let's see. That's question 9.
And then Shikash asked if, so is the equation y equals dx plus c the same as y equals mx plus c?
Yes, you can, yes, grade 11s. The dx plus c plus e, you just get different variables for the gradient and intercept. We usually say mx plus c. You can call it any other variable. It's exactly the same thing. Okay, I don't think I've got that question 6.3.
Okay.
Okay, so let's go into the next function question. The last one that I had for you, which is to sketch, here we go, sketch that parabola and that exponential. So let's try and just do it orally. Or what would we look at in terms of working out what that graph looks like? The first and most important thing is that my x squared is negative, so my parabola is going to do that. So grade 11s, whatever you do, don't lose the shape of that graph. It's going to be increasing, decreasing, so it has a maximum value. How will we work out the maximum value? The maximum value is always worked out with the axis of symmetry, which is x equals minus b over 2a. So we would have a minus 2 over a 2 times a minus 1, which would be negative 2 over negative 2, which would be 1. So that would be the axis of symmetry. And then if I substitute 1 back into my function, I'm getting a negative 1 plus a 2. So 2 minus 1 is a 1, and 3 and 1 is 4. So my maximum value, or my maximum turning point, is a 0.14. Once you've got that, you can solve for x, for your axis of symmetry, for your x-intercepts, and then you can just sketch that. What would this exponential look like, grade 11s? That is a reflection of your usual exponential with an asymptote of 1. So very simply and very quickly, you would get, instead of going through negative 1, you would get it going through 0, and there would be your asymptote, and there would be your graph. So that would be your exponential. It would look like that. And I'll leave you to just try it on your own, sketching negative x squared plus 2x plus 3 and 1 minus 2x. It does come from the exemplar question 9. So I'm sure your teachers are giving that to you. Over to you, Tebogo.
Thank you so much, Dina, for the wonderful lesson. I'm sure the Mind Sisters have really benefited. Thank you guys for tuning in. And a big shout out to Neo, Trish, Kelly Squared, Ndumiso, Tina and Tanya, Michael, Felicia. Guys, all the best with your exams. And I really hope you do well. With that said, good night.